Okay, thanks everyone. Let's get back to the conference. I'm happy to present my paper on the nature of nurture and nurture of nature, how genes and investments interact with informational skills. So this is joint work of my colleagues at Aarhus University, Nico Humark, which is a PhD student, and Michael Hosdom, who is a full professor. And the idea of this paper started when we started working in genetics data. We all do work on early skill formation, child development, and we try to think about how would it look like to have genes enter a model of skill formation? What are the different mechanisms through which gene would influence skill accumulation? So this is the first step at that question. The way we motivate the paper is to think that we all understand that individuals have different skills, so skills matters, right? We all know that these different skills surface early in life. A lot of people here have done work on this literature showing that how skill formation takes place. And we know that these childhood skills are important determinants of a variety of socioeconomic factors from marriage, fertility, income, education, anything that we think is relevant as a socioeconomic outcome. And we also believe that it's recognized this idea that we all know that genetics matter. We all know that family resources matter. The question is how to think about the two together into a model. So the idea is like, let's stop thinking about these two factors as independent components and try to think more realistically about how they interact. And another thing that we wanted to bring to the table is this idea that in especially a lot of earlier work, people think that genetic influences as this static and deterministic factor. So there's this heritability of 0.2 or genetic effect of 0.5. And we seem to think about this as a constant, like there is this genetic effect. But we're going to be showing you, hopefully you're going to be believing my results, is that genetic effects are actually dynamic. They change across the life cycle. They change across specific ages of the children. And they're going to be operating via these environmental channels. So it's not that genetics and family resources are independent. It's not even that they interact, in the sense that the return to genes are different across environments, is that a lot of the genetic effects operate via the environment. And this last part is very important because it also means that genetic effects are not fixed. It can actually be changed depending on social behavior. So in certain places where social behavior is one way, we should see genetic effects to be large, and in other places where social behavior is a different way, we might see genetic effects to be smaller. So that's kind of the motivation of the paper. What we're actually going to be doing here, we're going to be basically incorporating genes into model skill formation, as I promised at the beginning. And we're going to be discussing basically three main genetic mechanisms. So we're going to be saying that genes can influence skill formation via what we call a direct effect or child genes of skill formation. And just to fix ideas, when we say direct effect, here we're thinking about what most people think about what a genetic effect is, this idea that individuals with a different genetic makeup, they might have better abilities to learn new information and acquire new skills, right? But we're also going to be showing you that there are other channels through which genes can matter into the process of skill formation. The first one is what we call nurture of nature, which is this idea that the child genes can also influence parental investments. And this is like a long-standing idea in economics. It can go all the way back to the work of Becker and Thoms, this idea that parents can reinforce or compensate for additional differences in skills. And in our case, we're going to be looking directly at the genes by the PGS and looking at how parents reinforce or compensate based on that. And the third channel, which is also, I think, is very interesting, the interpretation is a little bit different, but this idea that parental genes might also matter in the process of skill formation. So it's not only that the child genes might influence parental investments, but the parental genes themselves might be an important determinant of parental investments. And this would explain, as I've seen before today, and the understock explain a lot of the effect of the association we see in the data between genetics and child skills can come through this other mechanism, which is not obviously as causal, right? It's actually operating through the parental genes. I'm going to be showing you that the three channels are important. The nature nurture, it's actually kind of interesting. It's kind of very similar to what the undershow. It explains about 50% of the whole effect. And of the remaining, this would be about 80%, and this is about 20%. So they're all important in different ways. Sorry, it's the opposite, 80 and 20. Building on these findings, identifying these mechanisms, I'm going to be showing you that genetic influences are dynamic, and opposite to maybe what I originally taught a few years ago, genetic influences actually increase as children age. So instead of like you're born with a certain genetic makeup and that influences your initial skills and that influence depreciates across time, what we're going to be seeing is that the initial influence is kind of small, but then it tends to accumulate across time because these direct genetic effects accumulate. So your genes do not only influence your initial skills, but also how you accumulate skills across the life cycle. And also because, at least in our data, we see this reinforcing mechanisms. So parents tend to invest more on children higher initial stock skills, and they also think to reinforce, invest more in children with higher EAPGS condition on the skills. So these two mechanisms tend to like kind of reinforce genetic influences across time. And then we're going to have this discussion, which I think is interesting, is the idea that genetic influences are not fixed, but actually can be changing social behavior. So here we cannot say very much with the data, but we can say with the model. So suppose now that parents had equal amount of investments across children, so we didn't have this reinforcing mechanism anymore, we can show that in principle, the genetic effects will go down substantially. And you can think about it in a country or in an environment or with parents that didn't reinforce the genetic difference, they actually compensated, then genetic influences would also going to be smaller. So there's this whole point about genetic influences not being fixed, but also depending on how parents allocate investments across children. So that's the idea of the paper. I'm going to talk a little bit about the data. The empirical model is going to be very simple model skill formation, discuss some of the findings, simulations, and if I have time, I want to discuss a little bit of the extensions, what are the things that we're doing during the current work. So the data we're going to be using, it's a different data set than I think anybody has presented so far. It's called the ALSPEC. This is a British cohort of about 15,000 children, and the children were all born in the same region, Avon in England, and similar years between 91 and 92. So it's like a cohort of children in the same region. So we're not going to have, unfortunately, a lot of geographic or time variation. But what this data set is great is that it has very detailed information on children's skills. I'm going to show you a little bit. It also has not as detailed, but it has good information on parental investments. And more important, it's going to have genetic information on the children, but also both for her parents. And this is going to be key, as Leandro's discussed today, about identifying the different genetic mechanisms. So our analysis is going to be in this small sample of children, about 1,200 from the 15,000. And a lot of the sample selection is due to missing parental genes. We believe that the issue is that a lot of the parents are not at home, but the fathers are not at home when the data was collected. So we're missing a lot of the data for some of the parents. What we have done already so far, I'm going to show the results at the end if I have time, is that we can impute some of these missing paternal genotypes and increase our sample substantially. And if we do that, the initial selection into the sample that we have actually goes down substantially. So this is like a very higher SES family than the average. Once we impute, we still have a higher than average SCS family, but the selection is much lower. I can talk more if you're interested. So in terms of measured skills, these are collected every 6 months from the child's birth until age 7. And these are basically primary caregiver rated measures of children developmental achievements. So for example, at ages 2 to 4, we have these measures of can the child combine 2 different words? And at ages 4 to 7, we have measures, for example, can a child read a story in more than 10 words from page? Let me just quickly show you the list of measures that we have. So this is like the measures that we have gathered from the data. So there's about 28 measures. And the key thing is that these measures, they are developmental achievements, so they change across ages, right? So they have different measures at age 0 to 2, 3 to 4, and 6 to 7, which is when we start observing these children because they enter in primary school. We also have a variety of measures of parental investments. And again, these are collected every 6 months from childbirth to age 7. And this basically, it's a compilation of different types of parent-child interactions. So we have information about the frequency of mother-child interactions. For example, the frequency that the mom reads the child. We have the frequency about partner or father-child interactions. It's always asked in terms of partner instead of the father. So the frequency of the partner shows child picture books. We also have information on child activities and access to resources. This is very crude. It's more like number of books owned by the child. Unfortunately, the family income variable collected from data sets is not very great. It's more categorical and it's very sporadic too. So we cannot do much from that. Just to give you a sense, these are the variables that we have in terms of investments. And these are more stable across the over time, but there's still some variation that might be interesting. Okay. In terms of genetic endowments, I'm not going to spend too much time on this, but because people already discussed this, but we're going to be using the EAPGS as our main measure of polygenic scores. And as people discussed before, the PGS is going to be a linear weighting of different SNPs, GISs. And we're going to be using for our main measure, I'm going to be showing you today in the EAPGS from the Lee et al. Paper that excludes the 23andMe data. If I had time, I want to show you some results where we try to correct for measurement error in the PGS. So we use 3 different PGSs to try to account for that, but the main results do not do that. I'm going to get back to this point in a little bit. So to fix ideas, I really like this graph, especially people that are not familiar with genetic data. So the reason why having the trio of the father, mother, and child is important is because of this process here. So imagine like the mother's DNA had like only these 7 variants, and the father's DNA has 7 variants, and here you have the child DNA. Whenever the mother has 2 letters in the same location, the child is going to inherit the letter with 100% chance, right? And the same thing with the father. The father has 2 A's here, the child is going to inherit an A with 100% chance. But the interesting thing is when there is variation in the father's DNA or the mother's DNA. So for example, the father here has a T and an A. And the question is like, which of these variants the child is going to inherit from the parent. There's a 50% chance the child is going to inherit T, and there's 50% chance the child is going to inherit an A, and that's completely random. And this is the type of sort of variation that if you have trios, you can identify variation in child's DNA compared from the 2 parents. And that's what Leandro showed at the beginning of the talk. And the interesting thing is that the child's PGS, which is going to be a linear combination of these variants, can be very different from that of the parent. So in this example here, it's 1.4 for the child and 1.8 for the mom, 1.7 for the dad. It can be lower or higher, and that's completely by chance of from the Mendelian randomization. So to make the point more clear, is like here we plotted the parental PGS, and the parental PGS is the sum of the mom's and the dad's PGS in deciles. So we have the deciles of the parental EAPGS, and here we have the distribution of the child EAPGS. And you can see there's a lot of variation, and some children born from parents at the lowest decile, they have higher scores than some children born from parents at the highest decile of the EAPGS. So even when we condition on parents' PGS, there's still a lot of variation in children, and we're going to be using the variation to identify the effect from the child genes versus that of the parent.
These numbers are deciles.
So this is normal. So this is the raw PGS for the child, standardized 0.2. So this is so this is the distribution actually. So this is the kernel density for the child's EAPGS for children from parents at the 10th decile, and that's for the 10th decile. And this is the distribution of the child's EAPGS.
It just means it's -1. They're 10 deciles below or something. I don't know.
1 standard deviation below.
Yeah. Sorry to interrupt.
No, that's great. Thanks. So the model is going to be, like I said, it's like the simplest model you can think about in the model skill formation. It's going to have 3 main components: the child initial skill endowments, the technology of production skills, and the investment policy function. The child initial skill endowments is going to have this form where we're going to allow the child and the parental PGS to influence the child's initial skills. And we're going to have some controls here. And we decided, so we had a lot of discussions about what should we include in the controls. And for our main results that I'm going to be showing you today, we decided to include things that are uncorrelated with the genes of both the child and the parent. So we're only going to be controlling for the gender of the child, and we also will be controlling for birth order. We could have included maternal education and income and things like that, but then this effect here wouldn't make sense. So how to interpret this alpha 2 is important. So this is basically the overall influence of the parental PGS, which could happen through education, through higher income. And also another thing is that the parental PGS, because we do not control for the grandparents, can capture other dynastic effects. So the grandparents effect and other family members. So the technology of skill formation is going to be just the Cobb-Douglas. So here we have the child initial skills at period T+1 is going to be a function for the child skills at period T. The investment the child is receiving at period T, which is like standard in the literature, and what we're going to be extending is just including the child's PGS and the PGS of the parent. So this is the new component here, and that's basically what we're interested in how these two PGSs influence the accumulation of skills of the children. And the third component is that we're going to have this investment policy function, which again allows the investment of the parent to depend on the skill of the child at that period. So this is gamma 1 is a traditional reinforcing compensating parameter. The parents reinforce compensate skills of the children, but then we're going to extend the model to include the child's PGS and the parental PGS here. So basically, looking at the simple model, we're going to think about genes influence skill formation via three mechanisms: direct genetic effects, the nurture of nature effect, and the nature of nurture effect. So just putting the three equations here together and just putting some colors for you to see. So basically the red colors here is what I'm calling the direct genetic effects. So it's the effect of the child's genes on the initial skills and the effect of the child's genes on the accumulation of skills over time. The blue color here captures what we call the nature of nurture effect. So it's the effect of the parental genes on the nurture of the child, which can happen at the initial skills. So you can think about this as in neutral investment. There's something that happened in neutral that's influencing the initial skill of the child, or very early investments. This, again, is the effect of parental genes conditional on investment on the accumulation of child skills. And this is the effect of the parental PGS on the investments directly. And the orange components here, this is what we call the nurture of nature effect. So how if parents invest more on children with higher skills and children with higher PGS, so they invest less in children with higher skills or higher PGS. So there's this reinforcing or compensating mechanism. So I already said this, but so the direct effect is these two components. The nurture of nature is basically these two other components. And then the nature of nurture is the parental genes effect on children's skill formation. So I'm not going to spend too much time on this, but we're going to rely on a factor approach to control for measurement error in skills and investments. The key idea is that allow us to compare the effect of genes over time if you believe the assumptions in the model. So different than other papers that look at literature, we can at least confidently say that if we find effects over time, they're not due because of measurement error. So we argue that it's not because of the initial skills have a higher measurement error. That's why we find lower effects early on than later on. And then it's going to allow us to do some of the counterfactual simulations, which is not going to be very complicated. So formally, people in the field know this a lot more than I do, but basically we're just going to assume this linear measurement error structure where we have different measures of children's skills at different time periods. And we're going to assume these measures are linear predictors of the log skill at period T, and the measures for investments are linear predictor of the log investments at period T as well. And we're going to be using the summation from Agostini and Wiswell. That's here. The inference is doing bootstrap procedure, where we sample individuals 100 a time times a random replacement. So one of the key things that we didn't do here is we don't control for measurement error in the genetics of the child. So technically we control for measuring their own skills and investments, but not in the PGS. In the extensions, I'm going to discuss a little bit, get a feedback on how to possibly control for measuring error in the genetics as well. So here's the main results. So basically we find that all the three mechanisms seem to be at least important and significant. So you can see that parents, so the child's PGS is predictive of initial skills of the children in red here. The child's PGS is also predictive of skill accumulation over time. We also find that parental genes are both important at accumulation skills, but also at investments. And we find no evidence that parental genes seem to influence early skills. If I decompose this by maternal and parental genetic effects, this first component here is significant for the mother, but not for the father, which is kind of suggestive of something neutral or like early investments being important coming from the mom. But importantly, what we find is these orange coefficients here is that parents tend to invest more in both higher skilled children and also children with this higher EA-PGS score. So even conditional skills, there seems to be some information in PGS. Here's insignificant, but if I do the robustness with the higher sample, this becomes significant. Parents tend to invest more on this higher PGS children. So there's some information about the children's skills, could be non-contact skills, which we would not include here, or it could be something else that parents are using to make the investment decision. So these parameters is hard to interpret. So what we're going to be doing to make things more interpretable is to compute what we call these PGS heritabilities of skills and investments. And heritability is like a very common measure in the field, which is basically the fraction of the variance of an outcome that explains by genes. In this case, is the EA-PGS, right? It's not genes entirely. So first, before I show the heritability, I just want to show you how it looks graphically. So one way to do that is we can plot the evolution of children's skills for children in the highest and in the lowest PGS quintile. And you can see for children in the lowest PGS quintile, they do have a lower development curve than children in the higher PGS quintile. Another way of seeing this is just standardize the latent skill at each of these ages. And the growth curve looks something like this. So you see that like over time, from ages 2 to age 7, we see that the dispersion of genetic effects seems to increase in children with the highest PGS versus the lowest PGS. There seems to be a larger gap over time. I'm just going to tell you some other results. So we did something similar in Denmark. So in Denmark, we have, so one issue with the Auspex, we as researchers, we didn't buy, so Auspex, you need to buy each the variable that you want. And we didn't have information after age 7. So we have to stop here. But in Denmark, we have very detailed information on primary school grades. And we see a very similar pattern starting at 2nd grade until the 8th grade. So this increase that we see up to age 7 seems, at least in Denmark, there's a different sample, different data set, to increase as well. So just thought I would mention that. In terms of heritabilities, here they are. What we see is that the effector genes seem to increase over time. And overall, at the latest period that we observe, from the calculations, it seems that about 7% of the variation in skills at age 6 to 7 seem to be explained by the EA-PGS of the child, and about 5% from the EA-PGS of the parent. And we can also look at the parental investments heritabilities, and they're about 6 to 8% can be explained by this EA-PGS effect. So we can also think about mechanisms. So what is the relative contribution of the 3 mechanisms? I already gave the answer from what I'm going to be showing you. But basically, the way we can do is we can use the model that the parameters we estimated and do a similar exercise that Matteo describes. We can just shut down some of the mechanisms and see how the relation between genes and skills change when we shut down this mechanism. Maybe we can compute the variation that is explained by each of the mechanisms, right? So here's like how the relationship looks. So here we have the percentile of the apologenic score, and in blue we have the baseline relationship. So how say moving from the 6 to the 8% of the APGS, how that changes the predicted standardized latent skill. And then we shut down the nurture of nature mechanisms, and it goes down for a little bit. And then we shut down the nature of nurture mechanism, and it goes down significantly. And then we shut down both, and then it gets a little bit flatter. So this gives a relative sense of the different mechanisms. We can also do this computing percentages of effects. And you can see that the number that I gave you, it's here. So about 50% of the genetic effects in total, the genetic association, right, is due to this parental genes effect, so the nature of nurture effect, which is very consistent to the rest of the literature, and also what Leandro shows, so that the coefficient goes down by half once you control for parental genes. And among the causal effects of child genes, 80% seems to be this direct, but still about 20% is this nurture of nature. So the reinforcing behavior of parents explains about 20% of the genetic effects from the child genes to the skill formation at age 6 to 7. And here, like, I just want to make that point, which is like, so what does this mean in terms of interpretation of a world where genetic influences affect children? And I want to make that point that genetic influences, the numbers that I'm giving you, they're specific to this context. And if parents didn't actually reinforce the investment in children, or they invest in children in a different way, we would see a different genetic effect. So here, for example, suppose that instead of having this, so this here in this left graph plots in blue, the relation between the percentile of the polygenic score of the child and the observed investment of the child, later investment. So we see this like very strong relationship between the child's EAPGS and parental investments. And the same thing here in blue, we have the modeled relation between the EAPGS and the skills at age 6 to 7. So suppose at every period we equalize investments in children, so there was this relation didn't exist anymore, right? How would that change the relation between the EAPGS and skills? And you can see that the line gets a lot flatter. So basically, in a world where we didn't have this reinforcing mechanism, or at least that we didn't see this relation between the EPGS and investments, the effect of genes will be a lot lower. We can do different types of exercises here. They all make the same point, right? So if we shut down the nurture nature mechanism, the heritability will go down significantly, basically. That's the point. Okay, so I'm about close to the end of the talk, so just going to give you some mention a little bit of the extensions we're doing. So we're doing basically like 3 different exercises. So the first one is to impute the paternal genotypes that we're missing. So that has 2 purposes. One is to increase sample size. So and to increase, like, give us more power to identify these effects. And the second thing is to kind of decrease a little bit the selection problem that I mentioned at the beginning. Because if you just select your sample to have paternal genotype, you're getting families where the father is present at home. And we don't want to have that necessarily. So basically we do the Alex method and we increase the sample size to about 4,200 children, so about 3 times larger. The second thing is, which I think is more interesting, but is less clear how to do, is to try to correct for measurement in the polygenic score. So let me just describe a little bit what we're doing, and then you can tell me if this is a good idea or a bad idea afterwards. So we were thinking about, so suppose we do the same measurement framework, but we think about from using the polygenic scores. So suppose we could have 3 different measures of this child genes using 3 different polygenic scores that are independent from each other in different ways. So one thing that we did is just getting the EAPGS without a 23andMe, which the SSGC provides, and then get the EAPGS using just the summer statistics from the 23andMe data, which we got from them. And then the third one is get the cognitive outcome PGS, which also comes from the Lee et al. Study. And they are, so these 2 are independent from each other because they come from 2 different samples. And the first and the third are independent from each other because they're looking at different outcomes. But if you assume that the 3 of them are kept in the same latent score and assume a classical error structure, maybe we can uncover and fix the measurement error problem. So this is the model we have in mind. So we have the three APGSs. We assume they are have a linear relationship with this G, which is the genetic score of interest. And we set the variance of G equals to 1, then we can identify these three latent factors and maybe correct for measurement error in our estimates, right? And just if you're interested, if we do that, latent factors are, so the highest signal seems to come from the UK Biobank, and then the 23andMe, and then lower from the COG PGS that we have. I can talk more about this if you're interested. And then the third one is allowing for non-linearity using a translog specification. So we also did that. So there's some issues. I'll mention that a little bit. So here's how the results change. Right. So I'm just going to show you the main heritability table because I think summarizes a lot of the results. So if you input parental genotypes, the results don't change very much. They get a little bit lower. So it could be something about the quality of the imputation. It could be because we're changing your sample. It's hard to know exactly why. But once we do the measurement error correction, this number increases significantly. It's about 25 to 50% higher effects overall. And then when we do the translog, there's some issues doing the translog with the imputation because there's some assumptions in imputation that might not translate into those nonlinear models. But if you do the translog, there's also some issues at the early ages, we get this negative effect, but at least at the later periods, we get something that's similar to the imputation. So this is something we're working on trying to make sense. But I think this was interesting results and worth mentioning. Okay, so let me try to wrap up and then we have time for discussion and talk. So we try to document the importance of both parental and child genes for child development. We show that genetic effects operate through social mechanisms. So both parents tend to allocate resources to children based on genetic makeup of the child. And we see that at least in the outback, we have this reinforcing behavior. And we also show evidence of this nature of nurture effects, this idea that parental genes matter for children's skill formation because parental genes are associated with parental investments. And these social mechanisms are kind of interesting and important because they show that genetic effects are not static, they're actually dynamic, and genetic and environmental effects interact, not just in the G by E sense, into a large existing inequalities and skills. And this later point that genetic effects are not fixed or static, they actually can be changed depending on social behavior. So yeah, I think, let me wrap up. Yeah, thanks.
I was just curious, so I'm having a hard time the measurement error thing you did. Exactly about it, but how much of variation in educational attainment can this latent factor account for? Because
so we don't have educational attainment in those parts, or at least I don't have access to educational attainment. But the R squaring, so this exercise shows increase about 50% higher effects, or 25 to 50%. So 25 for the parent and 50% for the child. Does that answer your question?
I guess, yeah, I don't know.
So this is a similar exercise to the GIV that is commonly used, right? It's very similar. But the key things here is that GIV, we need to know what is the variance of G. And to identify the variance of G, we need to know that to do these exercises. And if I just had two, like the GIV, like I just do the IV, I wouldn't be able to do that. So I needed three to solve that problem. There's a lot of other issues with the measurement error correction. One of them is that we're ignoring the difference between direct and indirect effects in the GWAS. So anyway, the reason I brought up is to get ideas of what people are thinking on how to do this. There was another question.
Yeah, it's kind of a comment on reinforcing versus compensating. So like 10 years ago, I have sort of a lit review with Doug Allman where we looked at, based on observables at birth, mainly birth weight, and parents reinforce or compensate. And there's sort of a bit of mixed findings and maybe a hint that it depends on SES of parents. So I don't know that directly translates, or if you've thought about that, or if it's just a caveat to the sample you have.
So that's the whole point. I think that's a little bit of what we're trying to say is that this reinforced compensating doesn't have to be true everywhere, and it can be different for different groups of individuals and different samples. It just so happens that in our sample, we see this reinforcing behavior. We haven't looked at heterogeneity yet, and the reason is because we had this small sample size, so we couldn't like just divide the sample, everything would be insignificant. But now that we have done imputation, we can, and that's something that we're thinking of doing. It would be interesting to see if we see this SES gradient in the reinforcing compensating mechanism. Yeah. Okay. Yeah.
Yeah, can I ask a question about your kind of idea about compensation or investment? Because I think the compensation does not sound like a between family completion. It rather sounds like a within family completion. That you have one smart children but not so smart, and you decide how to distribute your investment.
Yeah.
But I think your design is a between family design as well. So I'm wondering if this model or if this data is proper to test the compensation hypothesis.
So the way so that's a great point. Yeah. So it's about across children, but so these families, they don't have only one child. It's just that we only observe that one child as the focal child for the study. And the way we're thinking about this is that the expected PGS of the child is going to be the PGS of the sum of the PGS of the parents, right? And what we're seeing is that the deviation from the parent also has some information about the deviation from one child from the other child. So that's the way I'm thinking about this. But this is a good point. We don't have siblings in this data, unfortunately.
So first of all, I would like to thank the organizers of the conference for inviting me to this. It's been great fun this morning. And I definitely had a very good time. And I learned a lot from reading the two papers that I'm discussing, this one and the next one. The one apologist I have right away is that when I prepared my slides yesterday, I thought I was discussing first the other paper and then this one. So later on in the slide there is a reference to something I said before. I will say after, but it's okay. Okay, so as I said, I really enjoyed a lot reading this paper, and I generally say I learned a lot from it. What the authors do, they take seriously estimating a structural model where the object of interest is the production function for human capital. And they also estimate an equation for parental investment, which is an important input of these things. And, they refer to lots of papers. These are not randomly selected set of papers or that literature. As in the previous literature, they assume that child development is a function of current development, parental investment, and possibly some other variables. And they expand the current literature by allowing the effect of genetic variables, both by children and parents, to affect the level of development. Okay, and this is in the spirit of a paper by Wertz et al., but he has a much more economic, or the point of view of an economist, and a more structural approach to it. So I really like that. So following, the other thing that I liked a lot is the way they approach measurement very, very seriously. So they realize that the objects that populate these models are abstract concepts for which we do not have an exact measure, and we have a number of markers that are related to the concept of to the latent variables of interest through a measurement system. And they refer, to the literature that has developed. It's starting from following Cunha et al., but going both before and after that paper, including the contribution by Agostinelli and Wiswell, which has been important. And then they use this amazing data set, the aspect, where we have both information on the PGS for children and for their parents. And finally, having estimated this model, they use it to perform some simulations of and interpret the results of these models, and also perform some policy, if you wish, exercises. So as I said, I really, really enjoyed this, and I think this is a great paper. What I'm going to do in my comments, I will try to talk about 5 different issues. And these are dimensions in which I think the current work could be extended. In some cases, quite easily. In some other cases, it would be quite hard. The first thing I want to talk about is the endogenitive investment, and how they do mention that. And in fact, they do have an equation for investment, but how to deal with it. That's probably the aspect I was least satisfied with the paper, but I'll come to that. The second, and that could be one of the things that could be done relatively easily, I believe, and could have massive implications for their findings, in particular for the increasing importance of the genetic background, and which is the stationarity of the production function. So they say that the parameters that link the inputs to the outputs do not vary with age, and I would claim that this is a very strong assumption. The third thing is the role of beliefs, and I frame it in this way partly because that's something I've been thinking about quite a bit. But more generally, I think, and that refers also to the discussions of some of the other papers today, I think the next step, this research is really, really valuable, but the next step we need to go towards is a situation where we model parental behavior explicitly. And then we have the parents behave with some objective on the basis of a number of constraints. It could be financial or other type. Fourth is the different dimensions of development and different dimension of investment. Again, I don't know whether this can be done with this data set, but it could be important, and I'll say why. And finally, and this is a point that I'll be referring to in the other paper, commenting on the other paper, is the allocation of investment across different children, and how that is determined within family dynamics. Okay, so number one, the endogeneity of investment. So this is one of the things that I also discussed in the previous for the other paper, and there is a fair amount of consensus that parental investment is, especially in the first few years of life, is very, very important for children development. What is difficult is identifying the causal links that go from one input to the other. What is the marginal product of parental investment? So they mention this problem, and they have this investment as a function of lagged development. So there are these triangular structures in which they affect that. But I don't think that's enough, because I think there could be a number of other biases in that coefficient that that can be relevant. Now, I think this is a strong assumption, and not fully justified. In work that I have done in a number of different contexts and other people have done, when you run a simple regression by OLS and then you instrument the parental investment, in some cases with extremely plausible instruments, in other cases climbing mirrors and the like. But in many situations, we find, especially among poor populations, compensating effects. So parents tend to invest more when they perceive it's needed. So, which is different from what they find here. So that would be an important thing to explore, I believe. The second point is that I think the production function has changed with age pretty dramatically. Now, I don't think this is just an academic curiosity and being pedantic, can have very important implications for the work they do in this. In studying how the effect of genetics changes with age. You see, when I think about these production functions for child development, two of the parameters that are really important is the degree of persistence and the marginal product of investment. And we have evidence that changes with age quite a bit. And this is crucial if people have been in this literature have been talking about windows of opportunity. When, if you are designing policies to improve child development in certain contexts, when do you want to intervene? At what ages? And that's defined by these parameters. So letting them change is important. I have a paper which is an MDR working paper at this stage. It's co-authored with Raquel Bernal and Michele Giannola and Milagro Norris. We use we don't have genetic data there, but we use a fairly high frequency sample of kids from Colombia observed from age 6 months to age 7. So it's similar to this one. And we have one measure per year. And we have a variety of dimensions and of development. So we have 3, what we call cognition, socio-emotional, and health. And we have some information on parental investment. And the two striking features that emerge, especially when you look at cognitive development, is that the productivity of investment, of parental investment, goes down dramatically. It's very high between age 2 and 4, and then drops out. Instead, the persistence goes up like a rocket. And so then, if you simulate with those parameters, you might, in a richer model where you introduce the genetics, the relative importance of genetics might increase, might perform quite different. As an aside, it's also important to look at different dimensions. What I just said, for instance, about the productivity of parental investment is true for cognition, but it's not true for social-emotional investment. So it might social-emotional development. So social-emotional development seems to be more malleable and more affected by what parents do, even for kids that are 5, 6, 7. Definitely not teenagers. Tell me about that. But which brings to the policy relevant question of what domains should be targeted at what ages. Again, the windows of opportunity story. So that's beliefs. I think it's important to start writing models where we're explicit about what parents do. And the way I like to think about this is that parents have an objective functions and that maximize that objective. And their behavior depends on the constraints they face, are resources, tastes. They might love more or less their children. And then what they think about the process of child development, what are their beliefs and their information about. Now, that doesn't mean necessarily to assume that for the behavior among you, that the parents are hyper-rational agents. They make all the right choices. They might have the distorted beliefs about the process. And indeed, in many situations, they do resonate with, this is a very, very nice book I read a few years ago by Annette Leroux, where she talks about different models of parental behavior, what she calls concerted cultivation, which is what middle class and upper class parents do, versus parents that just believe that children grow and you just have to let them grow. Now, it's true that it's not easy to disentangle the effect of beliefs or tastes without direct measurements of beliefs. And I think it would be nice to combine maybe this genetic information with direct elicitations of parental beliefs, and maybe we'll get there at some point. Number 4, I already mentioned that to an extent earlier on, but there are different dimensions of human development. I don't know whether this data is rich enough to allow you to model cognition and social emotional. Social emotionals are very hard to measure among young children, but they're very important. We know from recent contributions to the literature on inequality that social emotional skills are becoming more and more rewarded in the labor market, maybe because of specific changes in technology. Which is, again, when we talk about what are one of the first papers today is that where does inequality come from? Maybe it's inequality in human capital. The human capital has got many dimensions. And so inequality it depends on the inequality in the stocks, but depends also on the prices and the remunerations of the stocks. And so studying the different dimensions, it becomes very important. And, assessing the effect of genetics on all this, I would be curious to know, maybe this is completely my ignorance, where work exists on the relationship between polygenic scores and social emotional dimensions. The same thing can be said about investment. There are different types of investment that parents can do. They can buy books and toys for their kids, but they also can spend time doing stuff for that. And it can be the effects of these different types of investment can be different in different dimensions. So that's another direction in which it would be nice to expand this work, as well as the participation to these activities by different members. Could be mothers, fathers, but also relatives, grandfathers, older children. There's a beautiful paper I listened to a couple of years ago. I think it was in Tanzania, where kids who had an older sister would develop much faster than kids who had an older brother. And that kind of stuff is important. Which brings me to my last point, which is what the allocation of resources across children. So this is stuff that I will show you some nice picture from a paper of one of my students, but he'll have to wait a bit for it. But I think thinking of how parents behave, you need to think about how especially in parents with a low amount of resources, how they allocate resources across children. What is their strategy? Do they want to maximize the total human capital of their kids, or do they have a taste for redistribution among the kids? And in certain contexts, other dimensions can be relevant. I already mentioned the older sisters, but more generally, we've been doing quite a bit of work in India. Gender biases can be very strong there. And there are some other outcomes that parents might care of. And I think the direction of this literature should be that. And finally, we talk about parental investment, the decisions parents make. The couple is more often than not is not just the one unit. There are different preferences that mothers and fathers or different parents might have, and they might be relevant not just because of genetic differences, but also because there may be differences in taste and objectives and social norms or beliefs that might have. And who has control within the family of the ultimate decisions, the allocation of resources does matter. So to conclude, this is a great paper, and I think it's an important first step in integrating genetic data into structural models. We have seen some other examples today. The recognition is that the channels that drive the outcomes we're interested in can be very complex and difficult to identify. And I think the availability of genetic background data can provide us both more power and more precision in our inferences, but also allows us to gives us a help in identifying the causal links and the importance of different channels. So I hope that the dimensions that I indicated can be useful for future work, and that's it.